We're here today to talk about HVAC or HVAC. And we're going to look at HVAC in a forced air system primarily, but we'll look at it in other systems. Now, when we look at the acronym HVAC, the first one is about heat and the heating process. We can also look at that as in a cooling mode or cooling sense, because we can't really cool anything per se. It's a removal of heat. And if we remove heat, it leaves something cold. And you guys know how the refrigeration system works, and that's really what we're referring to here is moving heat around. So be it a heat pump type of a system where we can remove heat from indoors and expel it outdoors, or we can remove heat from outdoors and bring it indoors. And that's how that system works. So we're thinking of the heating and cooling in the H here. Okay, it's the removal or moving the heat around. Sense of what a forced air system looks like. We have our air handling unit at the front corner of the basement installation, the top view here, and it has our ductwork. From there think of it as a big circuit, and from the air handler, air is getting pushed into the room, and then it's getting pulled back to the air handler itself. So it gets pushed through the supply line, it's called, where the heated air is, and it gets pulled back to the unit through the return air system. And this just shows us two different installations that we could do, one in a basement to accommodate the upper floor and one in the attic to accommodate the lower floor. It just gives us a basic of what that system looks like. Even though we're dealing with forced air, we can also have it in a hydronic sense, so with a boiler and a water system. You're going to work in the same fashion. The heat exchange is going to work the same way, but this is not a forced air system. Okay, it's still in the heating, ventilation, and air conditioning side of things, but really you can't have any ventilation here, and you can only condition the air so much because we don't have that forced air system to help move things around, move the air. We rely on natural ventilation in this instance. So again, just a nice picture of our unit. We have the furnace there. That could be a oil furnace, a gas furnace, or a heat pump air handler, or an electric furnace. So the unit itself could be any type of system, and they're going to be the same. And you see in this one that the flue vent, the round pipe, comes off the top, and then also the conditioned air comes off the top, be it heated or cooled, it doesn't matter. Heads out the top, goes through into the room, gets distributed throughout the building, and comes down, returning at the bottom of the unit. And notice the electronic air cleaner, the filter, the air is always filtered in our systems before it enters our unit. Heat pump it's very common for us around our area, around BC, milder climates. Heat pumps are fabulous. They're really efficient, and they can do both operations, the heating and cooling. And they just work really well here because we don't get too cold. Now we have heat up until about, I think it's around negative 260 degrees, meaning that we can pull heat out of the outside air and heat our homes in the wintertime via a heat pump, even though it's maybe 0 degrees or minus 1 or 2 degrees. There's still heat outside, and being able to pull that temperature out and heat our homes with it is still using the refrigeration cycle. It's like we first talked about the HVAC, where the H is not just the heating, but it's moving of the heat. And the heat pump is where we take advantage of this. And ventilation, or the V, refers to fresh air being introduced into a building or a home. And ventilation is really important, and it goes along with the last part, but ventilation, when we think of ventilation, if we just continually recirculate air in a building without introducing fresh air, we can actually contaminate that air with merely carbon dioxide. So if you have enough people in a room and it's totally enclosed, no fresh air coming in, eventually all the oxygen will be depleted and you'll have nothing but carbon dioxide, which then becomes toxic or poisonous because there's no oxygen left. So we need to bring fresh air in. We also need to expel or get rid of contaminated air. So be it more of an exhaust type system, which would be a form of ventilation, is just the introduction or refreshing of the air in the system. And then the last two, air conditioning. And really we don't want to think of this as the refrigeration cycle or cooling a building or home. We want to think of it more as conditioning of the air. Okay, and this can sum up the whole HVAC as just the AC part, because heating or ventilation is part of conditioning the air. But really with the AC part, we're thinking of filtering, removing of toxins. We're thinking of indoor air quality. We're thinking of comfort levels. We're making the buildings and houses and rooms comfortable to be in. And it takes all sorts of different aspects to accommodate that. So don't think of the AC as air conditioning in the refrigeration sense, but conditioning the air to whatever it takes to make it comfortable. Okay? If we had the air conditioning cycle or refrigeration cycle included in our acronym, we would add an R to it. HVAC-R. Heating, ventilation, air conditioning, and refrigeration. Okay? But we're not dealing with the R today, so we leave it at HVAC. So important to keep in mind, not just the refrigeration cycle here, but conditioning the air in whatever way is required.
In an effort to reduce energy costs, buildings have become better insulated and sealed, reducing the amount of air infiltration into the structures. Although this has reduced energy consumption, the air in these structures is becoming increasingly polluted. To make matters worse, people, especially the elderly, the very young, and those with illnesses, spend as much as 90% of their time indoors. In this lesson, we will examine indoor air quality and the principles of psychrometrics. Air contamination and pollution can come from a wide range of sources. Let's discuss a few here. The first pollutant is radon, a colorless, odorless, and radioactive gas. The main health risk of breathing air polluted with radon is lung cancer. Radon is released when uranium breaks down. Another common pollutant is environmental tobacco smoke, more commonly known as secondhand smoke. Reducing a source of contaminants can be very easy or very difficult. In the case of secondhand smoke, the easiest way to remove the source is to prohibit people from smoking indoors. In the case of radon, however, the abatement process is time-consuming, very costly, and must be done by trained professionals. Other common pollutants include household products, such as paints, varnishes, cleaning products, disinfectants, pesticides, asbestos, and lead. Two other pollutants that have come to the forefront of concern are carbon monoxide and mold. Carbon monoxide is a toxic, colorless, odorless, and lighter than air gas. It is produced by incomplete combustion in fossil fuel burning appliances. Combustion tests should be performed whenever the system is serviced to be sure that carbon monoxide is not being produced. Mold can produce a variety of health problems in humans. The problems vary with the type of mold as well as the quantities. Mold only needs moisture and food to grow. The food for mold can be dirt, dust, wood, or a wide range of other substances. Air conditioning duct systems are perfect breeding grounds for mold. As we mentioned earlier, the best solution for solving the problem of air contamination and pollution is to remove the source of contamination altogether. This is not always possible. There are things that can be done, however, to reduce the concentration of air pollutants and contaminants, such as providing adequate ventilation and cleaning the air. By increasing the amount of outside air brought into the structure, the concentration of air contaminants and pollutants can be reduced. If air is brought into the structure, an equal amount of air must be removed in order to prevent pressurizing the interior of the space. Indoor air quality can be improved when proper ventilation procedures occur. Commercial buildings are often designed with mechanical ventilation. Ventilation has a negative effect on heating and cooling efficiencies, as the air that is brought in from the outside must be heated or cooled to maintain the desired comfort level. The heat recovery ventilator, known as the HRV, is a mechanical method of providing ventilation to an occupied space. The HRV uses two ducts that penetrate the shell of the structure. One duct brings outside air into the space, while the other discharges air to the outside. The amount of air introduced to the space is equal to the amount removed. Both ducts pass through a heat exchanger. In the summer months, cooler air is removed from the structure and warm outside air is brought in. In the heat exchanger, the warm outside air gives up heat to the cool discharge air, so that the entering air is not as warm as it would be if it were not cooled first. In the heating months, the warm discharge air gives up its heat to the cooler outside air before being introduced to the space. This heat transfer helps maintain system efficiency. Air cleaning can be accomplished in a number of different ways. Mechanical filters and electronic air cleaners are among the most popular air cleaning methods in use. Fiberglass filters are typically mounted in cardboard frames and are a disposable filter. They are coated with a dust-holding adhesive that helps prevent particulates from migrating downstream. Pleated filters, also called extended surface filters, are made of a cotton-like material that can accumulate heavier, more restrictive particles at the bottom of the pleats, leaving the sides open longer for effective filtration. Because of the extended surface of the filter, they do not clog as quickly as standard filters. The high-efficiency particulate arrestor, or HEPA filter, is used where the highest degree of filtration is desired. HEPA filters can remove 99.99% of particulates having a minimum size of 0.3 microns. In order to be called a true HEPA filter, 100% of the filters must be tested at the time of manufacturing to establish the actual rating of that particular filter. Each true HEPA filter must be stamped with a serial number as well as the results from the filtering test. Electronic air cleaners are multi-stage units that not only filter the air, but also aid in the removal of odors from the air as it passes through the unit. They can be configured in a number of ways, but the most popular is to have the cleaner incorporated into the duct system of a forced air heating and air conditioning system. These cleaners are often equipped with 4 stages of filtering. The first stage, the pre-filter, traps larger particles and airborne contaminants. In the second stage, the ionizing or charging section, particles are charged with a positive charge. These particles then pass through a series of negatively and positively charged plates. The charged contaminants are repelled by the positive plates and attracted to the negative plates. The air then passes through a charcoal filter, the 4th stage, to remove many of the odors and gases by absorption. Air ducts are often a contributing factor to the amount of pollutants that are present in homes and buildings. Having a duct system cleaned should be considered if there is substantial mold growth, indications of infestation, or if there is excessive dust in the duct or on the supply registers. Duct cleaning generally refers not only to the cleaning of the interior of the ductwork, grills, diffusers, and heat exchangers, but the cleaning of condensate drain pans, fan motors and housings, humidification equipment, and the casing of the air handler as well. When cool air infiltrates a structure in the cooler months, it is heated upon coming in contact with the warm air in the space. When heated, the air expands and the moisture in the air can now occupy a larger space. This reduces the relative humidity of the air. Residences should ideally be maintained at a relative humidity of 50%, but it can be in the range from 40 to 60%. Higher humidity increases the growth rate of mold and other organisms. Low relative humidity can draw moisture from carpets, furniture, woodwork, plants, and people. Because the relative humidity of the air in an occupied space is low in the cooler months, mechanical devices called humidifiers are often incorporated into the forced air system to add moisture to the air. Evaporative humidifiers work on the principle of providing moisture on a surface called a media and exposing it to the dry air. Since the air is drier than the wet surface of the media, moisture evaporates from the media and is introduced to the air in the duct system. Evaporative humidifiers are available in a number of different styles. The bypass humidifier is mounted on either the supply or return duct of the forced air system. Piping is connected between the humidifier and the other duct, creating a connection between the supply and return ducts. The bypass humidifier contains no fan or blower and relies on a difference in pressure between the air in the supply duct and the air in the return duct to supply the needed airflow through the humidifier. The plenum mount humidifier is mounted in the supply plenum or the return air plenum. The humidifier media is located in the path of the air, which is forced through the media, absorbing moisture. Humidifiers are often controlled by a humidistat. The humidistat controls the motor and the heating elements in the humidifier. The humidistat has a moisture-sensitive element, often made of a nylon ribbon. Dry air causes the element to shrink, which activates a snap-action switch and starts the humidifier. Another type of humidifier is the atomizing humidifier. Unlike the evaporative humidifier, the atomizing humidifier introduces tiny water droplets into the air. These droplets evaporate very rapidly into the duct air stream or directly into the conditioned space. Because the atomizing humidifier is spraying water into the duct, the furnace blower must be on when the humidifier is on. There should be an interlock between the blower and the humidifier that will prevent the humidifier from operating if the blower is not. Comfort is achieved by maintaining and adjusting various factors in the space. One of the more difficult tasks is to achieve comfort for all occupants of the space. Unfortunately, this is not possible, since everyone has a different concept of comfort. In general, maintaining a comfortable environment involves controlling 4 factors: temperature, humidity, air movement, and air cleanliness. The rate at which we absorb and give off heat determines our comfort level. If we cannot give off heat as needed, we will feel warm. If we give off too much heat, we will feel cold. By regulating the rate of the heat transfer between the body and the surrounding air, we can create a comfortable environment for the majority of the occupants. Typically, when the body is at rest and in surroundings of 75 degrees and 50% humidity with a slight air movement, the body is close to being comfortable. The majority of people will be comfortable at the design conditions just mentioned. The study of air and its properties is called psychrometrics. Air, as we know, has weight and occupies space. Air also exerts pressure on the objects it surrounds. For example, the pressure of the air pushing against this card prevents the water in the glass from rushing out. Density is the unit that describes how much 1 cubic foot of a substance weighs. In the case of air, the density is about 0.075 pounds per cubic foot. The number of cubic feet required to make 1 pound of air can be obtained by taking the reciprocal of the density. The reciprocal of the density of air is 1 divided by 0.075, or 13.33 cubic feet per pound of air. This is referred to as the specific volume of air. Another property of air is humidity, or the amount of moisture contained in a given air sample. In order to maintain a comfortable environment, it is recommended that the relative humidity be between 40 and 60%. Humidity is in the form of water vapor. The moisture content in air is measured by weight and is expressed in pounds or grains. 100% humidity under typical conditions can hold 110.5 grains of moisture per pound of air. There are 7,000 grains of moisture in 1 pound of water. Relative humidity is the ratio of the amount of moisture in the air sample divided by the capacity of that air sample to hold moisture. If an air sample has the capacity to hold 110.5 grains of moisture, but is only holding 55.25 grains, the relative humidity is 55.25 divided by 110.5, or 0.50. This means that the relative humidity in the air sample is 50%. The moisture content of air can be measured by using a combination of dry bulb and wet bulb temperatures. Dry bulb temperature is in the sensible heat level of air and is taken with an ordinary thermometer. Wet bulb temperature takes into account the moisture content of the air. To measure the wet bulb and dry bulb temperatures, we often use a sling psychrometer. The sling psychrometer is made up of 2 thermometers. One of the thermometers is kept dry and takes the temperature reading of the air. The other thermometer is surrounded by a wet wick. If the air surrounding the wick is very dry, the moisture from the wick will evaporate. As the water evaporates, it absorbs heat, causing the temperature reading on this thermometer to be lower than the temperature on the dry bulb thermometer. Drier air will cause more water to evaporate, resulting in a lower wet bulb temperature reading, while very humid air will result in a wet bulb temperature that is very close to the dry bulb temperature reading. In order to take a wet bulb temperature reading, we must swing the sling psychrometer in the air for about 1 minute, like this. After 1 minute, we can observe the wet bulb and dry bulb temperatures right on the thermometers. We can see that the wet bulb temperature is 62 degrees, and the dry bulb temperature is 66 degrees. Using this device, we can also determine the relative humidity. If we line up the wet bulb and dry bulb temperatures we just obtained, the arrow will point to the relative humidity of the air. Another important air property is the dew point temperature. This is the temperature at which moisture begins to condense out of the air. Air can be dehumidified by passing it over a surface that is below the dew point temperature of the air. One example of this is the evaporator in an air conditioning system, which cools the air as well as dehumidifies the air. Common air pollutants include radon, household products such as paints, varnishes, cleaning products and disinfectants, pesticides, asbestos, mold, carbon monoxide, and lead. The concentration of pollutants and contaminants can be reduced by removing the source of the contamination, increasing ventilation and air cleaning. The heat recovery ventilator is a mechanical method of providing ventilation to an occupied space while recovering heat. Mechanical filters are used to remove particulate matter from the air. Some filters are disposable, while others can be cleaned for continued use. Electronic air cleaners use a multi-stage filtering and cleaning process to effectively remove particulate matter and odors from the air. Duct cleaning involves the cleaning of the interior of the ductwork, grills, diffusers, heat exchangers, condensate drain pans, fan motors and housings, humidification equipment, and the casing of the air handler. Humidifiers are incorporated into the forced air system to add moisture to the air. They can be evaporative or atomizing devices. Comfort can be achieved by maintaining and adjusting various factors in the space, such as temperature, humidity, air movement, and air cleanliness. The study of air and its properties is called psychrometrics. Common air properties include dry bulb temperature, wet bulb temperature, relative humidity, moisture contents, specific volume, and heat content.